Let me start our presentation. My name is Hyunhee Chung, and I applied research scientist at SOCAR, the largest classroom platform in Republic of Korea. I'll briefly introduce our paper entitled Phantom of Benchmark Dataset, Resolving Label Ambiguity Problem on Image Recognition in the Wild. I will start with our background and motivation of our work. Recent advancements in deep neural networks accomplished supreme success in various computer vision applications based on public benchmark datasets. One implicit consensus on this public benchmark is that each label space is well designed. However, due to a label ambiguity of the natural image samples, we argue that this assumption is not always justified, especially in the real world. During the dataset acquisition procedures, several samples frequently exist that are inherently ambiguous to be assigned to a particular class. We denote these samples as ambiguous samples. As these ambiguous samples have attributes of multiple classes simultaneously, they can be labeled differently following the annotator's bias. We presume this is inconsistent labeling demerits learning representation on each label. Thus, we necessitate a solution against it. Here is the sample of ambiguity dataset. For the example, in the first column and second row, we can see tadpole with legs. Which label you will annotate, frog or tadpole? This is ambiguous problem. There exists some prior works that deals with ambiguity problem. While prior work solves this label ambiguity problem by generating multiple weak annotations on these ambiguous samples, they require a particular amount of resources consumption for labeling. The practitioner should employ many labelers. To improve this limit, we tighten this assumption. The practitioners can acquire one label per sample. And our contributions are as follows. First, we propose in-depth elaboration regarding the label ambiguity problem. And second, we suggest the Consistent Sample Selector, CSS, a novel solution that solves the label ambiguity problem. We empirically examine that our CSS escalates the classification performance compared to other baselines. We scrutinize the underlying reasons behind our CSS supremacy in resolving the label ambiguity problem. Before, we propose a new framework that selects ambiguous samples that has consistent knowledge, examined ambiguous samples, indeed degrades the classification performance. We firstly classify that the careless use of the ambiguous samples indeed degrades the classification performance in every dataset. To take further step, we interestingly find that the pattern of the aforementioned negative impact differs following the ambiguity ratio. Consequently, as the landscape of the performance degradation differs following the data characteristics, we expect the solution against this label ambiguity problem to be established adaptive to the label space and the obvious samples characteristics. And here is our approach, Consistent Sample Selector, CSS. In the first step, we generate the initial classifier. Then second, we select the ambiguous samples with consistency. And the consistency term is on the right, and this term reflects the confidence and uncertainty of the initial classifier's output. And finally, we train the classifier with the selected consistent dataset. And then in this slide, we validate the effectiveness of our CSS. Discover that the proposed CSS accomplished the best classification performance in every label ambiguity type. We additionally compared to UPS, and UPS is the state-of-the-art of the pseudo-labeling area that eliminates narrative learning, as CSS was beneficial in understanding ambiguous samples. And this is our final slide. We additionally examined what drives improved inductive bias. We discovered that CSS requires less similar representation landscape compared to the others. Thus, it enables the model to acquire more knowledge. With regard to this representation landscape is fewer similarities to prove that CSS allows the model to illustrate wider knowledge. That's all I prepared. Thank you for your listening.